more about all this at the end of the video, but right now let's get to the video. In the preceding, we saw how to construct Pascal's triangle with the help of some blocks until we saw the pattern. And we've observed that combination 4C, 6C4, or C of 6,4, which is equal to 15, we ran through that calculation, appears twice within Pascal's triangle. Now, before we see the connection between Pascal's triangle and combinations, we're going to want to number the rows of Pascal's triangle, and then we're going to want to number the elements in the row, the numbers that appear in the given row. So, the top row we're going to call row 0. We're going to start with 0 in all the numbering as well as the positions. So we start with row 0, then the next row is going to be row 1, the next row is going to be row 2. You should have a copy of this. I recommend you do, but if you completely understand it, it won't be necessary. You can do it in your head. But label the remaining rows. Hopefully you paused and done that. Now, the positions along a row, we start from the left, and the first number in a row is going to be at position 0. The second will be, not surprisingly, at position 1. The third at position 2, and so forth. Can you label the positions of the remaining numbers in this row? Hopefully you've paused and done that, but we see I've included the labeling now: row 3, 4, 5, 6, and row 7. And positions, just using P to stand for position, position 3, position 4, 5, 6, and 7 within the row. And I'm certain everybody would get that. Okay, then what? Well, what's the row and the position of the 15 that we have here? And of course, you could think, what's the row and position of the 15 that we have here? So, what do you think? Pause. I'm going to write this in, but I'm going to do it off camera. I'm not going to make you watch me write it. Pause for a second. Write that in, see what you think. Well, it's really clear that this is in row 6. And what's the position of this 15? Here's position 0, 1, 2, 3, 4. So that's row 6, position 4. You'd also note that this 15 is at row 6, position 0, 1, 2. Now, what does that have to do with this combination? Well, it's row 6, position 4. It's combination 6, 4. And this should be combination 6, 2. So you might want to try to do C of 6, 2. Does that equal 15? Question mark? Okay, well, you can work it out and you'll see that it's true. Okay, so what we're saying then, if we let N and R stand for the number of our row and position, that C of NR occurs in row N at position R. And that's a general rule. Now you just want to be careful you don't start with 1 counting the rows, or you're going to be 1 off in the row, and that you don't start with 1 counting position. Rows start counting with 0, positions start counting with 0. And now we have a handy picture of as many combinations as you might want to write out. And I suggest that you write out the remaining, write out 4 more rows so that you have the first 10 rows of Pascal's triangle. You'll find that very handy in analyzing questions that relate to combinations. Now, if you go beyond about 10 rows, you're really better off just calculating your combinations using the formula. But Pascal's triangle, it doesn't take long to list 10 rows, and it gives you a little exercise in your arithmetic, and gives you a very handy reference. It can save you a lot of time. Okay, if you're still with us, the address at which you can find access to well over 2,500 videos, more than 300 hours, is http://vhmthphy.vhcc.edu/ vmenu.html. Videos covering all college transfer courses taught at my institution in mathematics and physics, including calculus-based engineering physics up through multivariable vector calculus and introductory ordinary differential equations.